And welcome back, AP Calc students. Time for another FRQ. This question is from the year 2018 on the AB exam, and it is question number 2. Question number 2 means this is a calculator-based question, and upon a quick read of the given information, you conclude pretty quickly that it is a PVA question. And PVA is an AP standard because they love the fact that with position, velocity, acceleration questions, they can give you velocity, have you derive to get acceleration, and integrate to get position, and it covers a whole lot of calc skills. And adding this to a calculator-based question means calculator skills and the ability to give you a more advanced or sophisticated function. So this is the general idea for this one. Also, I want to mention that if you recall, if our motion is vertical in nature, what they will do, instead of a P, we don't get that usage. If it's vertical motion, position will be expressed as S of t, not a P. But if the motion is sideways, position will be expressed as X of t. And that notation can just plain be confusing. This particular question is sideways motion because the particle is moving along the x-axis. So you want to be prepared that when you see x of t, you don't get thrown by it. You also want to be prepared to never expect p, and that you won't see s on this particular question. So sideways motion, position, x of t, no surprises. It especially looks odd when you throw a variable in there. Okay. So let's see what we have here for this particular question. It says a particle moves along the x-axis with velocity given by v of t equals, and this is a pretty beefy velocity function here. So we get v of t is equal to, and look at this, 10 times the sine of 0.4 t squared over the quadratic t squared minus t plus 3. Okay, so there's your velocity function that you're going to have to play with. And it also tells us that at x equals -5, or x equals -5 at time equals 0. Now what I'm going to write is that x of 0 is equal to -5, and I need to stress to you that this notation means the position at 0 is equal to -5. That's what this means because we're dealing with a sideways motion here. So this is what that means. So with that down here, let's move over here. Let's see if we can start to pick through this. This is a pretty calculator heavy question, and so there's a lot of little tedious parentheses issues we got to make sure we put in correctly. So part A says find the acceleration of the particle at t equals 3. Well, that's very easy since it's a calculator question, but the curve ball on this one is, can you put that in your calculator correctly? So, and just for practice sake, you would never do this because you have your calculator, but since we have the function, it never hurts to brush up on some keeping your skills fresh here. So I'm going to actually take the derivative here with, or the long way. I'm not going to evaluate it, but I'm just going to, or simplify it, but I just want to take it here because I need to figure out the derivative, which is equal to the acceleration. Okay, and PVA here going to one derivative, but I feel like just reviewing, see how gross this would be if you had to do the quotient rule. Ugh, it'd be terrible. So let's see, the derivative of the top would be 10 times the cosine of 0.4 t squared times the derivative of the angle, which would be 0.8 t, times the bottom, t squared minus t plus 3, minus the top, 10 times the sine of 0.4 t squared times the derivative of the bottom, which would be 2t minus 1, all over the bottom squared. Now, I think you can appreciate the fact that this being a calculator question, you don't have to do that, and then can you imagine substituting in the value? It wants this at 3, so you'd have to put 3 in here for each one of these. Oh, it would just be terrible. So we don't want to do that. We want to just take advantage of our calculator. So I'm actually going to erase that and just go to the calculator and show you how that works. Okay, So in the calculator, we are just going to take advantage of the derivative button, and what we're going to do is do d dx, and then we're going to put in, the calculator is going to ask for the function, and we're going to put in the velocity function based in x because that's how our calculator is, and then it's going to ask us to put in a value for x, and we're going to put x is equal to 3. So that's going to be the notation our calculator is going to ask for, and then we're going to put that in. And again, you just want to be careful here with parentheses and such. Okay, so under the math menu, down at number 8 here, we have the derivative. My variable is x, and now let's go ahead and put this in. I'm going to put parentheses around my numerator here. So I've got 10 sine 0.4 x squared, and that angle is closed, and there's my numerator, divided by, the denominator is x squared minus x plus a 3, close that, and they want this evaluated x is equal to 3. And we'll let the calculator do the work, and we should be getting negative 2.118. And that's what we get. Now, again, this question, we don't have a real-life situation with some product being moved. This is just a particle on the coordinate plane, so we don't have any units of time or units of distance. So, but if this was another type of question where we're dealing with actual movement of a vehicle or of a person, we would have miles per hour, for example, and if it was acceleration, it'd be miles per hour, or we'd be squaring the units for time, but not relevant for this question. So that actually was just a 1-point question. Can you put that in your calculator and evaluate it? So 1 point. B. B says find the position of the particle at t equals 3. Well, like I was mentioning before here, and well, now we have to go the other direction. They're going to want us to integrate. So we integrate position, but you have to be careful because you have to take into consideration initial condition. So I'm going to write this down. If I want to integrate, if I want position, I need to integrate velocity. So it wants it at time equals 3. So I'm going to go from 0 to 3, and I'm going to integrate my velocity here. And since I'm integrating velocity, the result would be the position at 3 minus the position at 0. Now I'm purposely putting position just abbreviated there, just so we're okay with that, but also knowing that what I was mentioning over here, this is going to be expressed with x. So they're going to say x of 3 minus x of 0. Okay, that's what you would see. And what the question wants is it wants the position of the particle at time equals 3. So this right here is actually what they're asking for. So if I want to solve for that, I need to add the initial position to the other side. So we're actually getting x at 0, which is my initial position, plus the integral of the velocity. And that's going to equal my position after 3 seconds. So that's what we're solving. And again, we're going to take advantage of our calculator's ability to integrate for us. Now, the other thing is, I have this written over here, but also in the question it says the particle is at position -5 at time equals 0. So this is actually given right here as -5. So it's going to be -5. I'll just throw that in there. Integral 0 to 3 of v of t dt, and that'll give us x of 3, which is what we're looking for. Now it's time for the calculator. So I'm going to go to here, and on my math menu, I'm going to go down to number 9, which is my integral. But actually, and I decided I'm going to actually put my -5 in front. It's easy to forget to include that, and you'll just lose a point for a careless error. So I'm going to put the -5 in front of my integral, plus, and then I'm going to put in my integral, which is number 9. Okay, and I'm going to integrate from 0 to 3. And now I have to put in this velocity function. Just again, I have to be careful with parentheses. So here is my numerator. Parentheses, I've got 10 sine 0.4 of x squared. And that is my numerator. I'm going to close that. I'm going to divide by, and here's my denominator, x squared minus x plus 3. And I'm hoping you don't get confused by the interchanging of x and t because of the way the calculator is designed, combined with using x to represent the variable for position. That's where just annoying little things can be confusing that way. And there we have that with integration with respect to the variable x. And let's see what we wind up with. Letting the calculator do the work. Negative 1.760. Negative 1.760. And again, we don't have any units here, so there is our answer. Okay? And that actually is a 3-point question right there. Okay, so just navigating that correctly. Okay, now part C. Part C is a great question. It says, first they want us to evaluate from 0 to 3 the velocity function, and then evaluate 0 to 3.5 the velocity function, and then evaluate 0 to 3.5 the absolute value of the velocity. And so you want to ask yourself, what is the difference between the integral of velocity versus the integral of the absolute value? Actually, you can put a to b right here, versus the absolute value of the velocity. Now, if you can answer that question, you're in great shape. If you're wondering, if you have absolute value, you're going to find total displacement, or total distance traveled, we like to say. That's an easier one to get your mind wrapped around. Total distance traveled, whereas this just gives you displacement. Okay, so here's the best example. If you were to integrate the velocity of a rocket going in the air and then it comes back down, and you were to integrate this velocity, you would get 0 because the displacement is 0. It ended up right where it started. However, if you integrate the absolute value, you would get the total distance traveled. It might have went a mile in the air and a mile back it was 2 miles. But if you integrate just displacement, it's 0. The other example would be running in track. If, well, let's just say you can run 20 miles an hour, so your velocity is equal to 20 miles per hour. Well, if we integrate your velocity of 20 miles per hour around this track, you're going to get 0 for your displacement or your change in position, because the finish line is at the starting line. But if we integrate the absolute value of your velocity, we would get 400 meters, because that would be 1 lap. So it's a really important thing to keep straight, and they like to throw that at you in a PVA question all the time. So usually it's in the question, though, it's something like someone's running on a trail, or there's some trail that has this kind of behavior. There's a part where the trail backtracks a little bit. And so if you just integrate the velocity, you're just going to get this distance right here. It's going to give you the change in position there from here to here. That would be your displacement. Versus if you get total distance traveled, it's going to give you this distance, and it's going to add to it running back and add to it going there. Okay, so that's the difference between the two. But they want us to find them and then interpret what they mean. So I'm going to bet that after we do this, our answer for the absolute value is going to be a larger number than not. So let's go back to our calculator, and we'll take advantage of being able to do some editing. So I'm going to go back up to this question. We just did this for the last question. I'm going to hit enter, and I'm going to be able to edit. So what I'm going to do is backtrack to the beginning of the integral, and I want to get rid of this -5. I don't need that there, so I'm going to delete those 3 things. And then here in the integral, I'm just going to make that 3.5. Make that 0.5, not plus. Okay, so 3.5, let's see what we get. And our answer there is 2.843, or 44 rounded. Okay, so let's see, let's get rid of a little, give ourselves some space over here. And so this will be C continued here. So on the calculator, when we integrated from 0 to 3.5 of just the velocity, we got 2.844. Okay? And now let's integrate the absolute value. And let's see what that gives us. Okay? Now logic would tell you it's probably going to be a bigger number. So let's see what happens. So on this one, I'm going to go to my math menu here. I'm going to hit my integral, and I'm going to go from 0 to 3.5. But when I get into my integral, I'm going to go back to my math menu, go over 1 and the number, and grab absolute value. And now I'm going to re-enter. Here's my numerator, 10 sine 0.4 t squared, close the angle, close the numerator. Then that's going to be divided by, and we've got x squared plus x minus, we had that was minus x, then plus 3. Minus x and plus 3. Close the denominator, I think we're good. And now my variable of integration is the x, and let's see what we get here. Calculator does the work for us, and still thinking. And we get 3.737. It was larger, which is what we were anticipating. So let's go back to the question. It says evaluate them. We just did. Interpret the meaning of each integral in the context of the problem. This very first one is going to give us the displacement. This one is equal to 2.844, and we're going to write this is the displacement over, and we can say 0 less than or equal to t less than or equal to 3.5. Okay, and down here, this is the total distance traveled. And we can say, if we want, we can include by the particle. Over 0 less than or equal to t less than or equal to 3.5. That's a little too tight there. Particle over 0 less than or equal to t less than or equal to 3.5. Okay? And that's 3 points. So 1 point for your answers. There and there. And 1 point for, you actually would say half a point for each one of those, and then 1 point for the explanation for each, for a total of 3. Okay, so again, this has come up a fair amount of time over the year with what these PVAs, sometimes speed comes up, which is the absolute value of velocity, but about moving whether it's increasing or decreasing. But this one was the difference between the two. Nice, really important question. So I like that. Okay, let's do the last part. D. A second particle moves along the x-axis with position given by. Now, just even notation here, because it's the second particle, they put a subscript of 2, and this just looks weird. X sub 2 of t, and this is a really nice little quadratic here, t squared minus t, and it's over the same time interval. So that's that, and it says, at what time are the two particles moving with the same velocity? In other words, when are their velocities the same? Well, we have the velocity function for the first particle. That was this right here. And so they want to know, when is that velocity the same as this one? Well, remember, notation, so important here. This is the position function. Okay, so we need to take the derivative. So we need to take x prime of the position function, which is going to give us the velocity function of this second particle. And I mean, this is simple, 2t minus 1. So there is that. So the question is, when does this equal this over here? Well, we're going to take advantage of our calculator and just graph them. So I'm going to graph that, I'm going to graph that, and we'll see when they cross. Okay, so let's go to here. Y equals, and I actually have this entered. I entered this earlier. So there's the first equation, 2x minus 1. And here's the second equation, second velocity. And I put that in there. Okay, and then we're going to, actually I want to graph this back normal. So you have to, if you have a calculator question, even though in the 2020 AP, they're not calculator required, you might want to use this here. I'm going to show you. So a little sinusoidal, you can see it kind of looks like what we call damped oscillation. But you want to respect the time interval for this one. So this is just from 0 to 3.5. Well, that's what's really going to affect your window. So you want to go into the window, and then before we do that, just look at the height here. I mean, we can really zoom in quite a bit on this one. So I'm going to change my x interval from 0 to 3.5, and my y-axis I'm going to go up to like -5. -5 to 5 would be fine, maybe even -3 to 5. So my x minimum is 0. My x maximum is 3.5. Okay, my y minimum, like -3, would cover it, and it looked like it didn't go any higher than 5. And so let's graph that. Way easier to read that. So there was the that's the 2t minus 1, and then here was that sinusoidal. Crosses somewhere between 1 and 2. Looks like it's a little closer to 2. And then we just use our calculator skills here. Okay, so second function, calculate, go to the intersect, which is 5. First curve, yes. Second curve, yes. And then the guess step, if you want, you can toggle over to approximately where it is and just hit enter. And it looks like we get this at time equals 1.571 rounded, I'm seeing. Okay. That is when they are the same. Okay. If you want to make a nice little sentence, you can say the two particles have the same velocity at t equals 1.571. Okay, there it is. So that was a nice little PVA. I like this one. 2018, so 2 years ago. Question number 2. Reminder for you guys, this was a very reasonable question. The only difference for you would be doing this with functions you wouldn't need your calculator. So if this velocity function was maybe the denominator wasn't there, a little nicer coefficient, and then it would be something you could integrate. So same question with friendly functions. Very nice question. So that could be something you see. All right, so 2018, number 2, there it is. Thanks for watching, guys. We'll see you next time.